Begin reviewing for your first test here on rearranging equations and on doing conversions. So let's start here with all of these with rearranging equations. What you want to be looking for. Always find first what are you trying to get by itself. In this case, A. To get A by itself, what is it attached to? It's attached to M. It's attached by multiplying. To undo that, I need to divide both sides by what it's attached to. So the M's would cancel out. I'd be left with F over M is equal to A. So that's all I need to do because now I have A by itself. In this one, I need to get T by itself. It's attached to both R and N. So I need to divide by both R and N. And again, whenever I do on one side, I need to do the other. So those cancel each other out. I'm left with just T on the right, PB over NR as my answer. And then number 3 here, I have two things going on. I need to get C by itself. I'm squaring C and I'm multiplying by M. I'm kind of doing reverse order of operations. To get rid of a square, I need to take a square root, but I can't take a square root until this is by itself. So I first need to get rid of the M. It's attached by multiplying, so I need to divide first. So I'll have E over M is equal to C squared. Now I have the C squared by itself. To undo that, I need to do the square root of both sides. The square and square root cancel each other out, leaving me just C on the right-hand side, and then the square root of E over M is what's left on the left. So square root of E over M is my answer. And number 4, same thing. I need to get B by itself here. I'm going to do a square root eventually because it's B squared. I need to get rid of everything else first. So to get rid of the A squared, it's attached by addition. So I need to get rid of it by doing the opposite, which is subtraction. So when I do that, those cancel out. I'm left with B squared on the left. I have C squared minus A squared on the right. Now to get rid of that, B squared, I need to get it just B. Again, I'm going to take the square root of both sides as a whole. Always when I do a square root must be as a whole. So the square and square root cancel each other, and I'm left with C squared minus A squared, all under a square root on the right. Number 5, solving for B1. So here's B1 right here. It's attached with B2, which is all within parentheses, so I can't do anything with this until the parentheses are by themselves. That's the only way I can get rid of it. So I need to get rid of everything else first. So let's start by getting rid of the 1/2. I would do that by, it's attached with multiplying, so I would divide by 1/2, which is the same as multiplying by 2. So that gives me 2A is equal to B1 plus B2 times H. To get rid of this times H, I need to do the opposite, which is divide both sides by H. So 2A over H is equal to B1 plus B2. That's the only thing that's left. I can drop parentheses. Now I can get rid of this B2. It's attached with addition, so I need to do subtraction from both sides. When I do that, I'm left with just B1 on the right, 2A over H minus B2. I can't combine that in any way. I don't have any like terms, so I am done. In number 6, same idea. I got T. It is attached to an A by multiplication. But before I can divide both sides by A, I need to make sure this whole thing is by itself. So I need to get rid of the U first by subtracting both sides by U. That'll leave me with B minus U on the left equaling AT on the right. I'll get rid of, I need to get rid of the A because I want T to be by itself. It's attached by multiplication, that's why I divide. So B minus U all over A is equal to T. I'm going to skip number 7 for a moment, go to number 8 first. You want to get x minus 4 by itself first because it's all within the cubed root here. So to get that by itself, let me subtract g from both sides. That'll leave me with, when the g's go away, the cubed root of x minus 4 equaling 2a minus g. Okay? Now I have the cubed root by itself. To undo that, I need to take both sides, and what's the opposite of square rooting would be squaring it. Because it's a cubed root, I'm going to cube it. If I do it to that side, I need to do it to this side as well. Now I could go and expand this, but I'm just going to leave it just in this factored form of 2a minus g, the whole thing cubed. The cube and the cube root cancel each other on the left, so I'm left with x minus 4. Then, to get rid of the minus 4, it's x minus 4 here, so to undo that, I need the opposite, which is to add 4 to both sides. So those go away, I'm left with x equals 2a minus g, that quantity cubed, and then plus 4. All right, now number 7, that is the toughest one on here by far. I need to get c in here by itself. So to do that, I'm going to need to get this square root by itself first. Before I can do that, I will need to get rid of this minus b. Before I can even do that, because all this numerator is combined together, I need to get rid of the denominator. So that's what I need to do first, multiply both sides by 2a. So I'll have 2ax is equal to the numerator, negative b plus the square root of b squared minus 4ac. Now, to get the square root part by itself, because I'll need to square it eventually, I need to add b to both sides. When I do that, I now have 2ax plus b is equal to b squared minus 4ac under the square root. The reason it was adding b was because it was a negative b to begin with. My next step is going to be to get rid of the square root, which I will do by squaring both sides. When I square both sides, I will be left with 2ax plus b all squared, and the square and the square root cancel each other out, so equals b squared minus 4ac. The 4ac is all attached, so I need to get rid of everything else on this side first, so I'll subtract b squared from both sides to begin. So when I subtract b squared, I'll be left with 2ax plus b. That whole thing squared, and I've taken away a b squared. And that equals negative 4ac, because that's all that's left. Now, my last step, I have c attached with a negative 4 and an a. To get rid of it, I need to divide, because it's all attached by multiplication, I need to divide both sides by the negative 4a. And when I do that, I'm going to come, where do I have room? Bring it up here. Where I have some room over here, I have that whole thing, 2ax plus b, quantity squared, minus b squared, all of that over negative 4a is equal to, whoops, not x, equal to what was left, c. Now, if I wanted to, I could expand this out just so you can see what the last steps would have been. You would have 4a squared x squared. You would have plus, it would be a 4abx, and you would have a plus b squared, all from this expansion, minus b squared, all over negative 4a, equaling c. Well, you can see here, these are going to cancel out. They all have a 4 in them, and they all have an a in them. So I could even go one step further and say my answer here would be ax squared plus bx over negative 1 is equal to c. Or, which would be negative ax squared plus bx is equal to c. So this would be like the absolute most awesome perfect answer, but all I'm looking for is if you can get to this part right up there. All right, now the conversions part of this. Conversions are not that difficult. You just need to make sure you always know what you start with and where you're ending. So, painting 15 square feet of her house in a day. 15 square feet, fraction bar means per 1 day. I need to get to what? Something per week. How many square yards per week? So I need to get to square yards per week. So the steps I'm going to take to get there. I'm going to start with, I need to get from feet to yards. So get rid of feet. 3 feet is the same as 1 yard. What canceled out? My feet and one of these feet up here. I still have a foot left because it was foot squared. And I only have 1 yard, I need square yards. So I'm going to do the exact same conversion again. 3 feet for 1 yard. Now both feet are gone. Now I have 2 yards, square yards, per day though. I need to make it per week. So to change days into weeks, there are 7 days for 1 week. 7 days for 1 week. That means my days have gone away. My unit now is yards squared per week, which is what I wanted. So now I can just go and multiply across the bottom and across the top. Across the bottom is 9, across the top is 105. I do that division and I should get like 11.7 yards squared, square yards per week. And number 10, Lindsay walked 4 miles yesterday. So 4 miles, it took 1,000 steps to do that. So it's 1,000 steps for the 4 miles. 4 miles per 1,000 steps. I need to get to inches per step, it says. How many inches per step did she take? Well, I already have miles per step, so that part's fine. I just need to change the miles part into inches. So I'll get rid of miles. 1 mile is the same as 5,280 feet. But I don't want feet. per step, which is what I have right now, I need to get to inches per step. So I'll change foot being the same as 12 inches. Now my unit reads inches per step, which is what I want. Now I can multiply across and divide, and I get 253.4 inches per step. Make sure you have your unit in there with it. All right, last three. A faucet loses a half a milliliter every second. How many liters does it waste in a month? So 0.5 milliliters per 1 second is where we're starting. And I need to get to liters per month in the end. So I'm going to start by getting liters out of milliliters. So to do that, as always, is 1,000 milliliters for 1 liter. So that way now I have liters per second, but I don't want per second, I want per month. So I need to keep going here for a bit. I can go from 60 seconds, converting that to minutes. So now it's liters per minute as my unit. I want liters per month though, so I better keep going. 60 minutes is the same as 1 hour. Liters per hour, not enough. So let's go to 24 hours for 1 day. So that tells me liters per day, but that's not enough. I need to make it liters per month. So I'm going to put 30 days for 1 month. Now my days cancel, and now I have my correct unit, liters per month. So now I can multiply across, and I should get 1,296 liters per month as my answer. In number 11, Jerry's room, his room is 4.8 meters wide. Okay, he wants to know how much trim he needs. How many feet will it be if it's 4.8 meters? Well, we don't have meters per anything in this case. If you want to just put it over 1, that's fine if that helps you. We're going to multiply by this easy conversion factor, I need to get rid of meters, and it's even telling you what the conversion is. 1 meter is the same as 3.28 feet. That way my meters are gone. Now my only unit is feet, which is what I wanted. How many feet? So my answer will be just multiplying across 4.8 times 3.28, so I should get 15.744 feet as my answer. All right, and the last one, the marathon world record time. He ran 26.2 miles in 2 hours. So that means 26.2 miles is how far he ran per every 2 hours. He wants to know what the speed is in feet per second. So I'm going to need to change both the top and the bottom, miles to feet and hours to seconds. Well, I can do miles to feet pretty easily. 1 mile, we said, is the same as 5,280 feet. Miles go away, I now have feet per hour, and I want feet per second. So I need to change my hours here. 1 hour is the same as 60 minutes. So now I have feet per minute, but I need per second. So I need to change it to get rid of minutes, I need minutes up top, seconds on the bottom, so everything canceled. Now my unit says feet per second. I can now go and multiply across the top and bottom, and when I divide, I should get 19.2 feet per second as my answer. Well, there you go. There's your review on conversions and on rearranging equations. Hopefully you're in good shape and can start this off right.